we are going to graph the sine function as a parent function and later manipulate it with transformations. We begin with f of x equals sine of x. We're going to use primarily the unit circle and mostly the quadrant angles and their coordinates. We're going to begin by marking the scale on our x-axis. And that goes with the angle, starting at 0, then pi over 2, then pi, then 3 pi over 2, and then 2 pi. So 0 here, pi over 2, pi, 3 pi over 2, and 2 pi. And remember from the unit circle lesson, the sine function is defined by the y-coordinate on the unit circle. So at 0, the y-coordinate is 0, so sine is 0. There's a point at the origin. When we get to pi over 2, the y-coordinate is 1. So the sine function value is 1. Here's 1. So at pi over 2, we're up at 1. At pi, the y-coordinate is 0. So we're back to 0. At 3 pi over 2, the y-coordinate's negative 1. 3 pi over 2, the value is negative 1. And at 2 pi, we are back to 0. So these are the key points for one period of the sine function where it completes one full cycle. The sine function appears to be a wave. So if we look, it's kind of parabolic in shape from here to here, and then also from there to there. And that completes one full cycle, one period. It would continue if we keep going, and it just repeats itself. So we'll do something similar over here, and something similar over here. Some of the characteristics that we're going to want to know about trigonometric graphs, things like amplitude. Amplitude is the distance from the midline, which in this case is the x-axis, which cuts the graph in half, to the highest or lowest point. So it's that distance right there, which is 1 unit. The period is the distance that it takes to complete one full cycle of the graph. We started at 0, we ended at 2 pi. The distance from 0 to 2 pi is 2 pi. The phase shift is a horizontal shift which has not occurred here. So we could say none. And then the midline is the equation of the line that cuts the sine function in half. And that is the x-axis, or y equals 0. The function you see in red is the general form of the sine function. We are going to be graphing g of x equals 2 sine x. Some of the key characteristics of our sine graphs are amplitude, period, phase shift, and midline. Amplitude is calculated by the absolute value of a. Period is 2 pi divided by b. Phase shift is c divided by b. And the midline is the equation y equals d. So it's always a good idea to identify a, b, c, and d from the general form. So for this one, we do have a 2 being multiplied by the sine of x. So that's our a, 2. And b would be right in front of the x. And x is the same thing as 1x. So b is 1. C comes from subtracting after the x or adding after the x inside of parentheses, but we don't have any parentheses. So that has to be 0. And then d outside of the function, anything that's being added or subtracted, we don't have that either, so d is also 0. So making our calculations, the absolute value of 2 is 2. The period is 2 pi divided by 1. 2 pi. The phase shift is 0 divided by 1. 0, or you can just say none. And the midline is the equation y equals 0. As the equation of the midline is y equals 0, we're going to take a look and start at the period. We saw from the parent function that that's going to be 4 spaces out, as long as there's no phase shift. So I'm going to go ahead and mark 4 spaces out as being 2 pi. 1, 2, 3, 4, marked as 2 pi. A lot of other teachers are going to want you to mark all of these, which is fine. I typically don't do that. So now that we have that, we're ready to graph this. Remember from the parent function that sine, the sine function, has its first key point on the midline at 0. So 0, comma 0. And then at the next key point, it was up at its maximum value of 1. But this time, the a, remember, is also a vertical stretch. So we're going to stretch that point from 1 to 2. 1 times 2 is 2. So at pi over 2, we are, instead of being at 1, we are now stretched up to 2. And then the next key point is back on the midline. And then the next one would be below the x-axis or below the midline with an amplitude of 2. So that means 2 below. And then at the last one, we return to the midline. So those would be the key points. Now we just need to draw the wave that passes through those, where the first part is concave down and the second part is concave up. And there is f of x equals 2 sine x. Our next graph is g of x equals negative sine 2x plus 1. We're going to see this has a couple transformations in it. We're going to begin with a, b, c, and d. A is out in front. Negative implies negative 1 times sine of x. So a is negative 1. B is in front of the x. There's the 2. C, again, this one does not have parentheses. So C is going to be 0. And D, this time we're adding 1 outside the sine function. So that's going to be a positive 1. So the calculations, amplitude is the absolute value of negative 1. And that's positive 1. Always going to be positive because it's a distance. Period is 2 pi divided by 2. 2 pi divided by 2 is 1 pi. Phase shift is 0 divided by 2. 0 or none. And the midline, y equals 1. So when the midline is not y equals 0, that's the first thing I'm going to draw is the midline of y equals 1. I like to draw it as a dashed line, as it's just there to help the graph. It is not really part of the graph. Next, because there's no phase shift, I should feel comfortable placing the period. This time it's pi. And just like we've seen before, 4 spaces because of the 4 quadrant angles that we were looking at. So 4 spaces is going to be pi. We should be ready to graph the function. From there, at 0, sine starts on the midline, which we shifted up because of the d value. And normally, as we saw in the parent function, the sine function begins by climbing and going up. But this time our stretch value is negative 1, and we do know that that makes a reflection. So instead of going up, we're we're going to start by going down. So at the next key point, we're going to be down, amplitude of 1, down 1 from the midline. So here we're 1 below. And then the next one would be on the midline. And then we're going to continue going up through the midline and above. So we're now going to be 1 above. And we will always, for sine, finish on the midline. And we're graphing 1 full period. We want to make sure that this part's going to be concave down and this part's going to be concave up. And there's g of x. For our next graph, we're going to step it up a little bit. It's going to be g of x equals sine of parentheses x over 2 minus pi over 2. So again, we'll start by identifying a, b, and c in front of the sine. It just means 1 times sine. A is 1. B right there, a little tricky. It's basically B is what's being multiplied by x. X over 2 is the same thing as 1/2 times x. So B is 1 over 2. This time we have parentheses, so we have a c. You have to look here. The form is minus c, so our c is the pi over 2, and it is positive. This kind of ties back to other functions that we've looked at. Inside the parentheses, we tend to think opposite for our value. So c is positive pi over 2. And then d, there's nothing being added or subtracted. So d is 0. We make our calculations. Amplitude is absolute value of 1, which is 1. Period is 2 pi divided by 1/2. So 2 pi divided by half, we tend not to want to divide by fractions. It's a little bit easier to think of multiplying by the reciprocal. So instead of 2 pi divided by half, let's do 2 pi times the reciprocal, which is 2 over 1. 2 pi times 2 is 4 pi. The phase shift is c divided by b. Pi over 2 divided by 1/2. We'll use the same trick, pi over 2 times 2 over 1, and we're just going to get positive pi. And the midline, y equals 0. Now we're going to do a little side work here, because anytime that we have phase shift, we want to make sure that our standard scale is going to work. We are really hoping that the period, which we found out to be 4 pi, will equal 4 spaces, because that's what we've been working with. We want to see if this is going to work with our phase shift or a multiple of our phase shift, which is pi. So to get from 4 pi to pi, we're going to divide by 4. Divide by 4. If I divide the left side by 4, I'm also going to divide the right side by 4. And as long as we get a whole number of spaces, then we're fine. If we get something like 1/2, that's not going to work, so we would adjust our scale. But we're okay, so I'm going to go ahead and label 4 pi to be 4 spaces. Right, we're ready to start to graph the sine function. Typically, the sine function would start at 0 on the midline. The midline is the x-axis at this point, but we do have a phase shift, and a phase shift means a horizontal shift. Positive means we're going to go to the right pi units, and we've already said that's 1 space. So instead of starting here, we're going to shift 1 space to the right and start here. And then the rest of the sine function is exactly as it's looked before in the other graphs that we've done. A is positive 1, so we're going to start by going up. The amplitude is 1, so the next one's going to be 1 above. So at the next key point, we're 1 above, and then we return to the midline. And then the next one's going to be 1 below. and then we're always going to finish on the midline. And if we count from start to finish, it's going to be 1, 2, 3, 4 spaces. We've already labeled 4 spaces as being 4 pi, and that's our period, the distance that it takes to complete one cycle. So let's just finish up the graph. And we've graphed one period of this, one full cycle. Go ahead and get some paper out. Try this one on your own. Fill out the A, B, C, D, amplitude, period, phase shift, midline. See if you need to do any side work. Pause the video. Come back and see if you were able to get it. We're going to go A, B, C, and D. A is 2. B is 2. C is positive pi. Remember our form is minus e. This is minus pi. Positive pi. And D is negative 1. Amplitude is the absolute value of 2. Period is 2 pi divided by 2. Phase shift is C divided by B, positive pi over 2. Midline, y equals negative 1. Side work. See if this is going to work. We're hoping that pi, our period, could be 4 spaces. Pi equals 4 spaces. And we're looking for a phase shift of pi over 2, or a multiple thereof. So pi over 2. To get from here to here, we divide it by 2. Let's do the same thing over here. 2 spaces. As long as it's a whole number, it's okay. It should be good. I can set the period to be 4 spaces at pi. 1, 2, 3, 4 pi. And we have our midline y equals negative 1. We can draw that in. And we're ready to go. Sine is going to start on the midline. But we do have a phase shift of right pi over 2. And we said that that's going to be 2 spaces. So we're not going to start at 0. It's going to shift right. It's going to shift right 2 spaces. It's going to start right there. Now next, the amplitude is 2. A is positive 2. So it's going to start to go up. And the next key point is going to be 2 above the midline. So right here is the next one, 1, 2 above. And then the next one's going to be on the midline. Next one will be 2 below. I did not mark that, so we would need to have that on the scale here. So 2 below. And then we always finish up on the midline. So from start to finish, if we count it, 1, 2, 3, 4 spaces. That's pi, and that's our period. I just need to draw in the curve. There it is. Our last one is a little bit of a challenge problem. It has a lot of intricacies to it. Let's take a look and start the same way we always have: A, B, C, and D. A is negative 2. B is 2. C, in this case, a plus 3 pi over 4 means subtract negative 3 pi over 4. Or inside parentheses, think opposite. And then D is the negative 2. Amplitude is the absolute value of negative 2. Period is 2 pi divided by 2. That would be 1 pi. Phase shift would be C divided by B. Negative 3 pi over 4 divided by 2. Again, that's a little bit tricky, so if we think multiplied by the reciprocal, negative 3 pi over 4 times the reciprocal 1 over 2, we would get negative 3 pi over 8. The midline is y equals negative 2. And we're going to need to do some side work since we do have a phase shift. We are hoping that the period is going to be 4 spaces. So pi equals 4 spaces. And then we need the phase shift to be some sort of multiple of that. So right here, the 3 is not really important. It's the divided by 8. I need to know how many spaces 1 pi over 8 is. So to get from pi to pi over 8, I need to divide by 8. And if I divide this by 8, 4 divided by 8 is 1/2. So that didn't work. I don't want to have a fraction. It has to be a whole number. So it did not work. So 4 spaces isn't going to work. I do need it to be some multiple of 4 because of the way the coordinate system works with the quadrants. So I'm going to try 8 spaces. So again, I need to figure out pi over 8, and if I divide the left side by 8 and the right side by 8, 8 divided by 8 is 1 space, that's a whole number. So we're good. So I need to mark pi at 8 spaces. 1, 2, 3, 4, 5, 6, 7, 8. Marked as my period pi. Our midline is y equals negative 2. So I'm going to mark that. Then we're going to go ahead and get that first key point, which is on the midline, usually at 0, but we do have a phase shift of negative 3 pi over 8, so we're going to go left 3 pi over 8. Now 1 pi over 8 is 1 space, so that makes sense that 3 pi over 8 would be 3 spaces going to the left. So 1, 2, 3. There it is for our first point. Now the next problem is we would normally go 1 space to the right for our next key point. But if we do that, we're going to finish in 4 spaces. But that's not my period. I need to finish in 8 spaces. So to finish in 8 spaces where we have our 4 parts, 8 divided by 4 is 2. So every 2 spaces is where a key point is going to occur. Now let's take a look at our A. A is negative 2. So due to the reflection, sine's going to begin by going down 2 below the midline. So 2 spaces over is where the next key point is going to be, and it's going to be 2 below. 2 spaces over, we return to the midline. 2 spaces over, we're now 2 above the midline. 2 spaces over, we finish and return to the midline. Notice, start to finish, if we count, 1, 2, 3, 4, 5, 6, 7, 8. That's 8 spaces. And there's our challenge problem.